Hi guys, Mr. Reese here talking about Algebra 2, Section 2.1, Relations and Functions. Relation is like a general term. It's a pairing of input and output values, whereas a function is a very specific kind of relation. So it's a relation where each input is paired with exactly one output value. When we look at some examples of relations, there's a lot of different things that are relations. All three of these things are. When we look at this table like this is considered a function because each of the input values is paired with exactly one output value. Now that seems weird sometimes that, wait a minute, both of these are y values, output values are 6. That's okay because each input has its own output value. When we look at something like this middle term, this set of x's, here's where we get something that's not a function. Here we have an x value that is actually mapped to two different y values. So here x goes to 0, and here x goes to -5, and that's really a problem. That makes this second thing not a function. Similar happens here on this third. We call this a mapping diagram, where we have these arrows and this oval. Since c goes to 2 and to 3, that's a problem. This is not considered a function. So of these, only this first table here is considered a function, whereas this is just considered a relation. This is just considered a relation, but not a function. So one little key thing here when you have these kind of deals, you can say when x values repeat, you know you don't have a function. And that's kind of really the rule for this. When we're going through here, vertical line test is a really simple test that can show if something is a function or not. And the definition is given right there. Basically, this thing is a function because no matter where I draw a vertical line, it only touches once. Whereas you can see in the sideways parabola, this touches twice. Here, this thing touches twice. Neither of those things is considered a function. So vertical line test, or we sometimes call it the VLT, is a good test to see if something's a function or not. When you graph, this is a quick rundown of graphing. An XY plane, when we're talking about two variables. So when you see something like this, y equals mx plus b, you have two variables, so you know you're in a plane. M represents the slope, b represents the y-intercept. Probably something we already know from Algebra 1. When we graph something like this, we typically will start with the y-intercept. So you have that shown here at -3 on the y-axis. Then we'll do the slope. When we do the slope, it's kind of thing where we go up 2 over 1, up 2 over 1, up 2 over 1. So the rise over run, we can say that's 2 over 1. So we list a bunch of points, and then we go ahead and draw the line in to meet that. So simple equation here, and we'll kind of graph it by using the y-intercept and the slope. One other little quick thing, function notation. Function notation talks about a way to show input and output values and how they're related. We've seen f of x and y equals probably in Algebra 1, and this just goes to show you that these are really the same thing. There's really no difference between that and this. They show you the identical thing. If we're plugging in something, we plug them both into parentheses. Probably done this before. Go ahead and solve them out. Just the nice thing about function notation here at the end is function notation shows the input of 3 and the output of -3. Whereas when you talk about the y equals, you only see the output. So this is preferable to mathematicians because you get twice the amount of information. One other little quick topic here, domain and range. We're talking about domain, set of all possible x values, and the range is set of all possible y values. So in a table like this, it's really easy. We just say, hey, there's the domain there, and there's the range there. Notice that when something appears more than once, you don't have to list it more than once. In a different format here, if you have a list of numbers, all you have to say is, hey, all these x values, they're considered in the domain, and all the y values, those things are all considered in the range. So something you've probably done before in Algebra 1, just a little review. In a graph like this, sometimes we haven't done this before, but the domain is considering, let's say you had all these points, all the points along this graph. How many x values would we really be talking about? Well, here we'd say all real numbers for x, because this graph goes to the right forever, and it also goes to the left forever. Since that's the x-axis, all the numbers on the x-axis are shown. For the range, y is just greater than or equal to -4 because the lowest y value that we see here is -4, and all the y's of the graph all lives above that. When we're talking about a graph, that's kind of how we look at those things. In an equation, we talk about the domain being greater than -4 or greater than 4 here because imagine like 4 minus 4 is 0. If x was less than 4, like 3, You have 3 minus 4 is negative 1. Well, you can't take the square root of negative 1. So that's really not an allowed thing. So we'd say all the numbers 4 and above. The range, the square root of a number is always going to come out to be positive. You couldn't get the square root equal to a negative. It just doesn't happen. You can't have the square root equal to a negative number. That's why we'd say y is greater than or equal to 0. So the outputs have to be positive in this case. The inputs have to be 4 or bigger. These are things you'll need to know how to do. Thanks for your time in section 2.1.